Find the inverse Laplace transform of x of s is equal to 4s square plus 6 divided by s cube plus s square minus 2. So we can say there are three poles are there, as the order of this equation is 3. So there are three poles in x of s, and by trial and error methods we have to find the poles of this roots of this equation. So we have to find the roots of this equation. So we can find the roots of this equation like this. This 1, coefficient of 3 is 1, coefficient of s square is 1, and there is no coefficient of s, it is 0, it is minus 2. So we'll factor by trial and error method. We'll find the first pole by, it is 1 suppose. So here we can write it is 1, 1 into 1, it is 1, this is 2, 2 into 1, 2, so it is a 2, 2 into 1, 2, and it is 0. So we have the first pole here, s minus 1. This is a s minus 1, and the second equation is s square plus 2s plus 2. So we have first factor, and we have to also find the factors of this equation. So remaining two poles we have to find out, and this is the roots of the quadratic equation and the root of the quadratic equations. This equation we can also write s square plus 2s plus 1 plus 1. So this we can write s plus 1 square plus 1. So s minus 1 and s plus 1 square plus 1. So in this way we can write. So therefore the partial fraction expansion for the partial fraction expansion for x of s takes the form x of s is equal to a over first pole, that is s minus 1, and that is b1 s plus b2 divided by s plus 1 square plus 1. Now we have to find the value of this a, b1 and b2. So we have to find these values. The expansion coefficient a can be easily obtained by the methods of residues. So we have to find the value of a. So a is equal to x of s into this factor s minus 1 by letting s is equal to 1. So we have the x of s 4s square by 6 divided by this is the total factor in the denominator. So it is s minus 1. So x of s s plus 1 square plus 1. So this is value of x of s into s minus 1, letting this at s is equal to 1. So s minus 1 get cancelled. What is remain there? 4s square plus 6 divided by s plus 1 square plus 1. Now put s is equal to 1. So if you put s is equal to 1, you will get 4 into 1 square plus 6, 1 plus 1 square plus 1. So 4 plus 6, 1 plus 1, 2 square plus 1. This is 10. 4 plus 1, 5. 10 by 4. So it is a 5 by 2. It is a it is 10 by 5, it is a 2. So value of A is 2. Now we have to find the values of B1 and B2. How we can find the values of B1 and B2? So remaining expression coefficient, that is B1 and B2, we have to obtain by placing the terms in the right hand side. So we have the equation, this equation. Now I will write the x of s on this side, x of s. So x of s is this 4s square plus 6 divided by s minus 1, s plus 1 square plus 1 is equal to a by s minus 1 plus b1 s plus b2 divided by s plus 1 square plus 1. Now we have to multiply left hand and right hand side by this term s minus 1, s plus 1 square plus 1. So if you multiply this left hand side and right hand side by this, so what will be remain on the left hand side? It is 4s square plus 6. And if you multiply by this factor here, so this s1 minus s1 will get cancelled. So what will remain? A into s plus 1 square plus 1 plus b1s plus b2, and if you multiply by this factor, this will get cancelled. S this will get cancelled. What will remain? S minus 1. So we have to put the values of a. We have already got a is equal to 2. So 4s square plus 6 is equal to 2. And let me write like this: s square plus 2s plus 1 plus 1 plus we have to multiply this b1 s square minus b1 plus b2s minus b2. So this is a 2s square plus 4s plus 2 into 2 4 plus b1 s square minus b1 plus b2 s minus b2, 4s square plus 6. Now we have to find the values of b1. So value of b1, for finding the values of b1, we have to compare the coefficients, equate the coefficients, and therefore equating the coefficient of s square will give you b1. So we have to equate the coefficient of the s square. I am equating the coefficient of s square. So s square is 4, here it is a 2 plus b1, and there is no s square, only 3 terms are there. So 4 minus 2 is equal to b1. So b1 is equal to 2. So I have got value of b1 is equal to 2. Now I also require to find the values of b2. So b2 is the coefficient of s. So we have to equate the coefficient of s. So b1s, then b1s square and b1 this b2s plus b2. So I have to for finding the coefficient of b2, we have to equate the coefficient of this s0, because this is a coefficient of s0. So this is the s0 coefficient 6, equating coefficients of s of 0 will give you b2. So h0, so this is a h0, so 6, this is also h0, 4, and this is h0, sorry, this is h0 minus b2. So 6 minus 4 is equal to minus b2. So this is a 2 is equal to minus b2. b2 is equal to minus 2. So we have got value of 2. So we have to put this in the partial fraction expansion for x of s. So this will take the form like this: x of s is equal to a, we have got value of a is 2, a over s minus 1 plus b1s, b1 is we have got here, b1 is 2, b1 is 2, therefore it is a 2s, and b2 is minus 2 divided by s plus 1 square plus 1. So this 2s minus 2 we can write like this also, that is a 2s plus 2 minus 4. So minus 2 minus 4, it is a minus 2. So we can write this factor like this, and this we can further write, we can take outside s plus 1 minus 4. So instead of this we can also write like this. So we can write like this: 2 upon s minus 1 plus 2s plus 1, that is one factor, by s plus 1 square plus 1, and second factor it is a minus 4 divided by s plus 1 square plus 1. In arriving at second equations, we have factor 2s minus 2 in arriving at the second equation, we have factor like this. So x of s is, this is x of s. Now we have put this into the standard form. So s plus 1 by s plus 1 square plus 1, this is actually the Laplace transform of e raised to power minus t into cos of u of t. So taking the inverse Laplace transform, taking inverse Laplace transform, we get x of t is equal to this 2 into e raised to power t into u of t plus this 2 into, this is the actually the Laplace transform of e raised to power minus t into cos of t into u of t plus 1 over s plus 1 square plus 1. This is the Laplace transform of, so it is a minus value, minus 4 into, this is the Laplace transform of e raised to power t into sine t into u of t. So this is e raised to power minus t sine t into u of t. So this is the inverse Laplace transform for the given equation. Thank you very much for watching the video.